Sources of solar energy. The internal temperature of many of the suns, even your own, is much higher than is commonly believed. In the interior of a sun, practically no whole atoms exist. They are all more or less shattered by the intensive X-ray bombardment, which is indigenous to such high temperatures. Regardless of what material elements may appear in the outer layers of a sun, those in the interior are rendered very similar by the dissociative action of the disruptive X-rays. X-ray is the great leveler of atomic existence. The surface temperature of your sun is almost 6,000 degrees, but it rapidly increases as the interior is penetrated until it attains the unbelievable height of about 35 million degrees in the central region. All of these temperatures refer to your Fahrenheit scale. All of these phenomena are indicative of enormous energy expenditure, and the sources of solar energy, named in the order of their importance, are 1. Annihilation of atoms and eventually of electrons. 2. Transmutation of elements, including the radioactive group of energies thus liberated. 3. The accumulation and transmission of certain universal space energies. 4. Space matter and meteors, which are incessantly diving into the blazing suns. 5. Solar contraction. The cooling and consequent contraction of a sun yields energy and heat sometimes greater than that supplied by space matter. 6. Gravity action at high temperatures transforms certain circuitized power into radioactive energies. 7. Recaptive light and other matter which are drawn back into the sun after having left it, together with other energies having extrasolar origin. There exists a regulating blanket of hot gases, sometimes millions of degrees in temperatures, which envelops the suns and which acts to stabilize heat loss and otherwise prevent hazardous fluctuations in heat dissipation. During the active life of a sun, the internal temperature of 35 million degrees remains about the same, quite regardless of the progressive fall of the external temperature. You might try to visualize 35 million degrees of heat in association with certain gravity pressures as the electronic boiling point. Under such pressure and at such temperatures, all atoms are degraded and broken up into their electronic and their ancestral components. Even the electrons and other associations of ultimatums may be broken up, but the suns are not able to degrade the ultimatums. These solar temperatures operate to enormously speed up the ultimatums and the electrons, at least such of the latter as continue to maintain their existence under these conditions. You will realize what high temperature means by way of the acceleration of ultra-atomic and electronic activities when you pause to consider that one drop of ordinary water contains over 1 billion trillions of atoms. This is the energy of more than 100 horsepower exerted continuously for 2 years. The total heat now given out by the solar system sun each second is sufficient to boil all the water in all the oceans of Urantia in just 1 second of time. Only those suns which function in the direct channels of the main streams of universe energy can shine on forever. Such solar furnaces blaze on independently, being able to replenish their material losses by the intake of space force and analogous circulating energy. The stars far removed from these chief channels of recharging are destined to undergo energy depletion, gradually cool off, and eventually burn out. Such dead or dying suns can be rejuvenated by collisional impact or can be recharged by certain non-luminous energy islands of space or through gravity robbery of nearby smaller suns or systems. The majority of dead suns will experience revivification by these or other evolutionary techniques. Those which are not thus eventually recharged are destined to undergo disruption by mass explosion when the gravity condensation attains the critical level of ultra-atomic condensation of energy pressures. Such disappearing suns thus become energy of the rarest form, admirably adapted to energize other more favorably situated suns.